Using modern web security to a geriatric health sector. The Norwegian health sector is a complex thing, consisting of a lot of old systems, some new, and a lot of very old systems. We have been working a few years on introducing modern web security identity protocols in this sphere, and this is a story of how we do it right now. So, me and Rune, we are from a small company called OAuth2, 4 people. We work on digital identity, sharing of data, and security in general. Been doing this since OAuth2 was established in 2013, and yeah, mainly working with HelseID nowadays. And we do that on behalf of Norsk Helsenett, Norwegian health network, which is a provider of health infrastructure. They have a separate health network, alternative to internet in Norway, and they provide national services such as Helse Norge, Kjernejournal, e-prescription, e-resept, and are nowadays working on new national components which can be used in Norway. So, my name is Dag. I've been working within IT for the last 30 years, soon. Been working on security the last 5 years, developer. And nowadays I speak more than I code, but that's how it is. Rune?
Yeah, my name is Rune, and what to say? I've been programming since childhood, still doing that. And as Dag, talk too much, program too little. And we are working very closely with the technical side of the service HelseID that we're going to talk about today. Before we start, we need to do an introduction on the Norwegian health sector. But how many of you folks are not Norwegian, if any? Oh, at least 3. Okay, so we can do the introduction quickly then. So you all know about Norway, the best country in the world, blah, blah, blah. We're happy, and we're spread out. And not all of you know about the Norwegian health sector, so let's go into detail there. Norway has the ambition of offering the best healthcare system in the world. And we are more or less there. As you know, Norway is a long country with the population spread out, and therefore we are divided into 4 health regions in Norway. We have northern Norway, middle, western, and southeast. And each of these regions, they are separate organizations, and they basically are independent of each other. And on top of that, we have thousands of small organizations doing the primary healthcare. Doctors' offices, physical therapists, all kinds of apothecaries, and so on and so on. So we have a large number of small actors in addition to the large ones. And we have the national services. NHN, Norsk Helsenett, our customer, of course the most important one. But in addition, we have the People Health Institute, FOE, we have the Directorate of Health, Helsedirektoratet, and several other large organizations that offer common services. So you see that the ecosystem is quite complex. Lots of organizations, lots of people having an opinion. On top of this, the Norwegian health sector is governed by laws and regulations. If anyone of you attended Steinar, our colleague's talk yesterday on FAPI, he went into detail on that. So we won't dig into it, but we have lots of laws and regulations that control what we are supposed to do, how we are supposed to do it, what we are allowed to do in the Norwegian sector. And on top of all of this, since we are so fragmented, we also have a large number of software suppliers of all kinds. We have journaling systems from the brand new web-based modern applications down to the most old-fashioned, and that's where the geriatric word come in, old-fashioned type of applications on the desktop, and everything between. And each and every organization in this ecosystem can choose their own software, whatever they want to use, as long as it supports the requirements that are set. So you understand, this is a mess, basically. And that's what we have to handle.
All right, so a bit of history. Before 2012, Norwegian law said that you are not allowed to share health information with across your security boundary, across with external organizations in Norway, in a digital way. So people basically had to, when they wanted their health information, for example, from their doctor to some hospital, they had to go pick it up, get it on paper, a CD, USB stick, whatever, and carry it to the hospital. And this was dictated by law. This was changed in 2012, where the laws turned around, and suddenly it went from no-go to you shall share your digital health information. It shall be available when needed. So, as a consequence, right, first I can say that because of the law which said that you aren't allowed to share health information, people built, they secured their security domain with firewalls. Basically, they say no to internet. People working within a hospital or a doctor office was not allowed to use the internet at all, and that was the security. You got these walls, basically. And you go from that scenario to a scenario where you are suddenly going to share everything when needed. So, as Rune told you about, we have the health regions in Norway, which basically built up their own security domain with hospitals. They had some identity systems, etc. And you had some national services. You had the kommunene, the municipalities with their own systems. You had the private actors, of course. And then they were going to share information. So what happened in 2012 and some years forward was that each time somebody was going to share some health information with another actor, it was point-to-point integrations. They built the security. They determined how they were going to share the user identity of the health personnel, because you had to know who it was, etc. And this was point-to-point. Each integration was a new project. They had to determine how to secure it. They had to find out their own way of doing it. And of course, chaotic after a while. Not scalable, unsecure, etc. So the directorate of eHealth and eHealth, and HOD, Helsedepartementet in Norway, decided that this can't go on. We have to do it in another way. So what was decided was that we were going to build a national service for doing this stuff, both for authenticating users and systems and for sharing health information. We call it HelseID. And it was basically a single point, a single service, which provided in Norway, we are so lucky that we have some national IDs, which can be used securely, BankID, bypass, Confidis, etc. Also, we are so lucky that we have a national ID number, so everybody living in Norway have a unique number, which you can use to identify people. We integrated this service with these eIDs and told people that please integrate with us, and we will provide you with the necessary security and the information you need to share data. So HelseID is basically an OpenID Connect provider and an OAuth authorization server, to use the protocol speak. It's built upon a .NET library called the Duende Identity Server, which maybe some of you know, and has a lot of extra stuff, functional stuff. Just to ask, how many of you know OpenID Connect OAuth? Yeah, most of you. Good, okay. So, I won't go into details on the protocols, but basically, you have applications, clients as we call it. You have APIs, which provide data. And you have identity providers. Norway, of course, have ID-porten. We have, which is in front of eIDs such as bypass, Confidis. And also, we have local identities across Norway in the various regions, etc., kommune, municipalities. So the way this works is that basically in OpenID Connect is that when a user wants to log on, the system forwards the user to HelseID through a system browser or another browser. The user gets choose their identity provider, logs in. The user gets sent back to their application using the web browser. And then the application asks HelseID for a token if you want to access an API and uses that token to consume the API. But of course, this sounds easy, but it's not that easy. So Rune will tell you a bit about that.
Really easy, right? How many of you have set up an OpenID provider before? Yeah, everybody knows this. Terribly easy. So, how do we support the entire Norwegian health sector with one service? Not so easy as it should be. We needed to make this single authorization server support all the use cases. We have, due to laws and regulation, we need to know who the user is. We need to know information about the organization. And if we are going to share health information. On top of that, we have APIs that don't need that much information. For example, not all APIs need information about the user. So we need to not only support the OpenID Connect flows, but also the OAuth flows. And we're going to come back to this, but we have several requirements. How do we know where a person works, for instance? How do we handle that? And so we have many requirements. And on top of that, we know that, as Dag said, this is the single point of failure. And we don't want to stop. We don't want people to die. We're in the health sector. And also, if someone gains access to our service, if we are hacked, they gain access to everything. So we need to harden it. We need to secure the service. And also, we need to establish this trust. Establishing this common service, it needs to be trusted by everybody. And knowing the complex ecosystem with all the different software vendors, we know that we have to offer functionality that works across different programming languages, different platforms, and so on and so on. So the challenge, while the protocols are quite simple, but supporting them for all the use cases has been quite a challenge. I go into slight details on one part of that. We've been securing and hardening the protocols. As some of you know, the OAuth2 protocol was completed in 2012, I think. So, and the world 10 years ago isn't the same as now. You know, web browsers have gone a long way. The internet, how we use it, everything has changed. And it turns out that there have been discovered several holes in the protocols that have been. You can't fix it in the. You can't just fix a protocol because it's out there, it's in use. But instead, there are best current practice. There are recommendations on how to use OAuth, for instance, that say, don't use this and that feature, do it this way, don't do it this way. To go into details, for instance, in the OpenID Connect flow, where you have a user logon, one of the flows is the implicit flow, where the token is returned via the web browser. And there are many ways for an attacker to pick up this information. And once you have the token, you are the application and the logged on user. So we don't allow the implicit flow anymore. So on top of the security, the best current practices, we have the security considerations for how to use the protocols. We have a threat model and an attacker model. We've been studying these, and we do our own risk analysis, which features fit to the Norwegian health sector, which don't. And we have our own security profile. It's based on the FAPI2 profile. Do you people know FAPI? It used to be called financial APIs. Then in version 2, what do you call Steinar? Fortified APIs, because the financial sector, they have been using OAuth for a while, and they have narrowed it down, say use these features and not the other features. And we see that the requirements in the financial sector are not exactly the same as the ones we have, but we can build on that. So we build on the FAPI2 profile, and we have hardened it, and we use the parts of the protocol that are already standardized. The FAPI profile, it points to some features that are being standardized now. We are not using them yet. And there are some features that may or may not fit into how the health sector, the Norwegian health sector works. So we have the HelseID OAuth security profile. So let's see how much time. Time goes fast when you're having fun. We can't go into all the details, but for instance, we don't support a shared secret where a client software has a password. We always require that they use asymmetric crypto. So the client must use a private key to prove who they are, not just a password. We only support 2 flows. We support the authorization code and the client credentials. So we don't support the hybrid, we don't support implicit, and some of the others. We only support them. We always require the PIXI mechanism, proof of key change, where it's to protect against man-in-the-middle attacks. And on top of all of these, we have some requirements that are quite unique for our service. We recommend strongly that access tokens, the access tokens that a client asks for, are only for one service. This is to protect against tokens being stolen by or reused by an API against another API. So we require access tokens to only go against one service. And we also require access tokens to have a very short lifetime. It varies between 10 minutes and even down to 1 minute for some system. And this is just to make sure that if an access token gets in the wrong hands, at least they can't be used for a long time. So we have narrowed down, we have tightened the protocol, into our own security profile. Skal du fortsette, Dag?
Yes, so that's all good. Of course, we want it to be secure, but we also have the problem that it is a national service, so we have to be very clear on how people are going to implement it. It has to be very concise. As Rune said, the OAuth framework is very broad, so we have made choices to narrow it down so we can tell people how to use it exactly. Some of the decisions we have made is just to make the choice easier for the developer to how to do it. It make security choices for them. And that's good. That's good because then it's more simple for us to kind of give good examples, document, etc. Because we just say this is the way you do it. And some choices, as I said, is not based on security considerations. It's more like we made a choice. Very important for us is providing sample code. We communicate with a lot of developers who has no experience at all with these protocols, very little web experience at all, and they are going to implement it in an old system, typically a desktop system, and they come to us and how do we do this? We don't know. So at the start we were kind of talking to everybody, but suddenly HelseID got popular and it didn't scale. So nowadays we try to provide good documentation. We are a small team, so we have very limited resources, but we try to provide good samples and work with our documentation all the time. It's not up there yet, but we are working on it. Also very important is for such a service having a sound self-service solution. That's very important when you're going to scale. So we have a separate team working on a self-service solution for HelseID. Started with some concrete use cases and are expanding it now. The goal is that people in the future it will be possible for them in a secure way to first develop their system in our test environments, integrate with it, test it, etc., then promote it, probably with some acceptance tests or something, to the production environment. We have to have that in place to be able to scale nationally. Right. And looking... Okay.
Next slide.
Next slide. There we go. Forward. One thing we are doing right now is using Altinn for bootstrapping the authorization processes. Altinn is kind of a national service. Most of you know it, probably. It's used today, for example, if you are a business owner, you can tell that in accountant, he can do things on my behalf. We are using Altinn in the same way. So a doctor, a specialist, whatever, can tell that this company, which maintains my technical solutions, can do things on my behalf, for example, in the self-service solution. Another scenario is that you have large actors, large systems in Norway, which acts on behalf of a lot of health organizations. We also use Altinn to provide that functionality. So, say a kommune can that's a bad example. Helseplattformen, which maybe some of you know, which covers the whole of the middle of Norway, Helse Midt, can act on behalf of all the organizations in Helse Norge. We're using Altinn for that too. Also, we are using the protocols to for not security, but rather functionality. You have some a specification called rich authorization requests, which makes it possible to transfer, rather provide information from the clients, that is the EHRs, etc., information about the context of the user working right now, context about the information, the place they are working, etc. Provide that information to us in a secure manner, which we can include in APIs, in tokens, access tokens, which then can be trusted by the APIs. The point is that we are already building a trust between the clients, our consumers, and HelseID, which is technical, and the extra information provided has kind of the same trust level. And looking forward, I won't go into that, but as Rune said, we do have some requirements regarding how long a token can be valid, what kind of APIs it targets, few. And that's because we lack a mechanism of kind of providing linking an access token to an actual client who got it. Right now, if you steal an access token, it's free to use for all. But there are a couple of specifications which deals with what we call token binding, which is kind of tying an access token to a client in a cryptographically sound way. So we have something called mutual TLS and something called DPAP, which we are looking to support. Yeah, I think I will stop there. What time is it? Good.
We have plenty of time.
Going on.
Yeah. So, we have spent a lot of time narrowing down the protocols, sharpening them, tightening them, so they fit our requirements. But we have more challenges, of course. And the second large challenge that we have handled is actually the ecosystem. In Norway, and I believe in most countries, most hospitals, doctors, everybody, they use an EHR, an electronic health record system, where they record all the information about the patient, medication they got, the diagnosis, and so on and so on. And these systems, they are expensive. It takes a lot of work to make them. And there are many of them out there. And not to criticize the health sector, but it's when someone buys this system, they want to stay there, and the vendors aren't very open to changing and updating them. So we have lots of outdated old software out there that now has to support the modern web technology. So I'll tell you a bit about basically how you do it and what our recommendations are regarding that. So you remember this figure. We have HelseID in the middle. You have the EHR system on the bottom who talks to HelseID to get an identity. And then they can call some API. What Dag didn't mention was that to do this, you need a user agent or a web browser. To do a user logon in OpenID Connect, you need a web browser. There's no other way to do it. And that's it, because this is a web protocol. And most of the software in the Norwegian health sector is desktop software. Usually a Windows application built in the 90s. No, not really. They are updated, but not. It depends, you know. And they now need to support a web browser. And how do you do that? So we are combining this web technology and desktop applications using duct tape, more or less. We are combining these two worlds. We have done some, again, some risk analysis regarding this. And in OAuth, we are talking about credentialed clients and public clients. A credentialed client is a client that can keep a secret, something that not even the user has access to. And then you have the public clients that can't keep a secret. And typically, a single-page web application, it's a public client. Because in this web application, there is no way to store a secret, since everything is in the browser. And typically, a desktop client is seen as in the same way. The desktop client, the user can, if they want, dig out any information they want about that software on their computer. But we are in the health sector. And so we have lots of history to build on. And there are ways, even in a desktop environment, to protect the secret. And much of the software that handles this health information, they are client-server applications where you have a backend on a server somewhere that is protected, and you have this GUI, the front end, that communicates with the backend. And so we have done a risk analysis and have defined that even though it's desktop software, we can treat them as a credentialed client. They can keep a secret. And this is important for us because it opens up a better way to protect the client. So then they can prove who they are, and that's important for us. I won't go into too much details in that, but I'll show you the two patterns of integrating with HelseID. The first one, look at this beautiful figure, is here we have the desktop application, your Windows Forms or Java or whatever. And in this case, we have included the web browser as a component inside the application. And I'm guessing some of you have done this already. So you have most of the user interface of the application is in the old way with buttons and forms and so on. But then you have the web browser that can show some user interface. So you can extend the desktop applications with the web user interface. One of the ways to integrate with HelseID is to include the web browser in your application and tell that web browser component, go to HelseID and ask for a logon. The web browser will then open the logon page in HelseID, offer the user, here are your options for logging on. They click on, select BankID, whatever, log on as normal. And when the process is done in HelseID inside the web browser, the application can either watch the traffic in that web browser component and pick up, okay, this is the callback from HelseID. Now we can take the information that HelseID gives us back. Or they can run a tiny web server inside their application that picks up that callback. So when HelseID says, okay, you're logged on, go back to your application, go to localhost, some address or something, and that tiny web server can pick up that information. In both cases, the application will get basically an authorization code. That's the important bit here. This is a long random number that the application can then send to its backend, and the backend will talk to our, what we call a token endpoint, to get the identity token and the access token. This way, the web browser is part of the application, and if this application needs to open, for example, what is the Norwegian core journal, Journal, that is a web application that offers a UI that can be opened inside this browser. They will get a single sign-on because there's a cookie in that browser, and everybody happy. Then we have the other way. Here, the desktop application does not include a web browser. Instead, they communicate with the system web browser on the user's machine, if they have Chrome or Edge or whatever they use. In this case, the web browser will open a URL or it will ask the system web browser to open that URL and tell them, go to HelseID, do a logon. That URL also contains information that tells HelseID, when the user logged on, you go back to this address. And that will point to this tiny web server inside the application. So the user in the system web browser log on to HelseID, blah, 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 you know. And when they are done, the HelseID says to the web browser, go to this localhost address on the local machine, and the web browser is there, waiting for this callback. And from there, it's basically the same process. They pick up this authorization code, it's transferred to the backend of the application, and they can handle this token request call. The difference here is that the web browser on the desktop, the desktop web browser on the computer now has a cookie at HelseID. This means that if the user opens the web browser to run some other software that is protected by HelseID, they get a single sign-on, no matter how many. And that's actually part of the good thing about HelseID. We offer a single sign-on. And while in this case, you get a single sign-on, but only inside the desktop application. So you see, we have a trade-off here. In this case, where we have the integrated web browser, you get a much better user experience because everything happens inside your application. While in the second case, you get a single sign-on, and depending on what other systems the user needs, it's up to the software vendor to choose, really. In the security recommendations for using OAuth and OpenID Connect, there is a recommendation for how to do this. And they say, do not run an embedded web browser. Don't do that. There are many reasons for that. Maybe the most important is that when you run an embedded web browser, you usually don't show the address field. And in the case there is a hacker that sets up a fake HelseID, then there's no way for the user to see that this is a fake and not a real thing. In our ecosystem, again, risk analysis, we have determined that this is worth the risk. This is mainly due to the environment where the program runs. The doctor's offices, hospitals, they are lockdown environments. We are running mainly inside the Norwegian health network, which is a lockdown network. And the Norwegian health network, the organization, they are running the DNS, and they know what they're doing. So this is fairly tight and fairly foolproof, even though the recommendation is don't do it. So we allow the embedded browser, and most of our consumers running desktop applications use that pattern. So, talking on, where are we now? HelseID has been in production since 2018. So it's been a few years, 4 years old now. And we are now protecting most, if not all, of the national eHealth APIs in Norway, and most of the web services, web applications as well. We're not huge, but we do about 100,000 logons per week. During the corona, actually, this number doubled. So it's been really interesting to see now that the pandemic is going away. We can see our traffic slowing down to the pre-pandemic levels. It's been really interesting. So we issue about 1 million access tokens per week. So there's some traffic. We have about 500 systems, clients in our production environment, about 1,000 in our test environment. So you see, and these numbers, they're going to grow quickly with new systems coming on. So and that's the reason we need the self-service system. We are fairly early adopters of protocol extensions with FAPI and that stuff. So I think we're doing well. And the service is growing quickly. Dag mentioned what is called Helseplatformen. It's a single journaling system for entire middle Norway. We're really excited about that. They went into production today, just before this talk, actually. So that's going to be interesting. They're going to challenge us so many ways with how they use our service. So things are looking good. At the same time, we are experiencing severe growing pains. We have been more or less like, the startup. They're doing well, and then the product starts selling, and oh my God, we are 4 people supporting everything. We don't have the organization, so we are growing, and it hurts. So we have too many manual processes. For instance, in going to production, many systems have to do that manually. Our self-service system isn't ready yet. And we are working hard to cover the requirements of all the systems that are using HelseID. Our documentation, as Dag said, it's not good enough. We're working on that. And it's good times, it's fun, but it's quite stressful. It's going fast. So, and where we are going to the stars? We are aiming to do the self-service fully automated so that we don't have to do manual processes for new organizations or APIs that use HelseID. We need that. Manual processes are bad in so many ways. At the same time, we are working on improving the availability of HelseID. Right now, the Norwegian Health Network offers an SLA of 99.7%. We are working on increasing that so we reach at least a 99.9%. And the truth is that we can't go down. Then people won't get their prescriptions, don't get insight into the health information of your patients, so we can't stop. And that's a really interesting topic in itself. So, but that's for another day. We are looking at how to support mobile applications. At the moment, we're not there. And of course, sample code in more languages, better sample code, better documentation. So we have lots of things to do, but it's going well. Dag?
Yeah.
Yeah.
Yeah. Right. So we have been doing this. HelseID has been in production for 4 years now. We started at scratch, just built the service, put it in production, said, here it is, please use it. That's kind of, all vendors said, why should we use this? Why is it necessary? And why should we trust you? And the final point, why should we trust you? That one has been a long time coming. Because building the trust for a central service, which kind of can make your application break if it goes away, and it's in health, it's a big step. So we have kind of used these years to prove that point one, availability, we work all the time. We haven't had any downtime except for Norwegian Health Net infrastructure things outside of our control. We have worked hard on the security stuff. So we have been pen tested up and down a lot of times, and that has went well. We have worked a lot on communication. We have talked to the vendors. We have talked to the developers. We have traveled around Norway speaking about this. We have been available. Have our own Slack channel where we try to answer all questions when there are questions. If people have trouble, we talk to them, person to person, etc. So communication has been extremely important. Sample code, of course, for people getting kickstarted. Yeah, so that has been fundamental for kind of getting where we are today. Also, HelseID is part of a larger picture, of course, kind of sharing digital health information in Norway. It's a big deal. So Steinar, in the audience area, talked about it yesterday, is working on building kind of the larger framework around this. We are the technical bit of it, but it's a common trust framework for the Norwegian health sector for sharing health information. And there's a lot of other stuff going on. And that's going very well nowadays. Let's see. Yeah, the technical choices we have made has worked out. We used Dentist Server, now Duende. Beautiful stuff. We were on a .NET platform, so we chose that because of that. C# .NET works is good. It has all the support we need. We have very few dependencies. When we build HelseID, we try to have as few dependencies, both service level dependencies and library level dependencies as possible. So that's a pattern we use, and that works out very well in the .NET world. And of course, the choice of choosing a standardized protocol to do this, that we chose OAuth and OpenID Connect. That's also good. Yeah. So, okay. We have some time for questions, but before we take those, if you really like these protocols and are interested, Udelt is hosting the OAuth security workshop this year. So it's kind of the OpenID Connect Foundation and all the people working on the standardization stuff, which get together and kind of play around and discuss. And there's a lot of interesting talks, etc. All the best people in the world are coming from all over the world. So if you are interested, we have a few spots left. I don't. So.
They're decreasing in number.
Yeah.
We have a top of 90.
Yeah, 90. So that's May 4th to May 6th if anybody's interested. Just come and talk to us. In Trondheim.
Yeah.
In Trondheim.
Hometown.
So
I should also mention we are offering, Norwegian Health Network are offering the hackathon. So we are running a one-day course on how to get started using HelseID as a developer.
Here in Oslo.
In Oslo, in the start of June. There are still open spots there if any of you are interested in that. You find more information on the web page of the Norwegian Health Network. So, that's it.
Then we have time for questions. If you want to ask the question in Norwegian, it's okay. We will translate. We are not using Azure. We are hosting it private. Norsk Helsenett runs its own data centers where we host it. They're also working on a private cloud solution. Right now we are just running on Iron, not Docker, Kubernetes, anything. Probably going to move over to that when that is ready.
Is the clients you have built have other things and documentation? Is that publicly?
Yes, it is. Yep.
If you search for
open for pull requests too.
If you search for HelseID on GitHub, you will find everything. So, one more question?
Yes. It's an actual separate network from the internet. They have their own infrastructure, which is provided to all health organizations in Norway.
The Norwegian Health Network, it is a physical network, but they also support VPN access into that network. So it's possible to go that way as well. But it's still a public network because there are so many actors in it. But there is an own health cert organization that monitors everything that's going on. So it's considered a more secure environment than the internet, at least.
Actually, they have their own frequencies on the backbone.
Yeah. Sir?
What was the hardest thing when creating this?
What was the hardest part of creating HelseID?
Yeah,
that's a good one.
Yeah, patience probably.
I was going to say that.
Yeah, because the health sector moves slowly, and it's not like even though when we build something, it's not like it's going to be used tomorrow. It's going to be used in a year, and when it's used, you can't change it because there are a lot of dependencies. People have to change the code if we change anything. So we can't break things. You first and then you. Yeah.
How do you test the solution? Do you use
Yeah, you're talking about the test data? Yeah. That's quite easy for us, the test data bit, because we don't really keep identities. We are just...
you don't care about the
No, the data is transformed between the clients, our clients' applications, and the APIs. That's where the health information flows. While what we do is just provide a user login and tokens to access the APIs.
But with that said, we have a separate test environment where all the test environments of the national eHealth services are running as well. So we have synthetic test persons. So when you log on using a test bypass card, you will get a name of a synthetic person. And the same way we have the health personnel registry in its test environment that gives us information. And then you will get access to the test version of Kjernejournal and e-prescription and so on. So it is a completely separate environment.
I think there was a question more there and then there.
I just have a follow-up question before you mentioned that you have kind of or you can't change so much after
Yeah,
what happens when
when
there are bugs?
there are,
Yeah, so
we don't have bugs.
we don't. I don't have bugs. So the question is, since it's very difficult to change things when we are in production, how do we handle bugs? And sometimes we do have breaking changes, but we have to report them very early, give a warning, and gradually introduce them. That's basically the question. And we've been quite lucky so far. We haven't had any serious bugs in the features that we offer that we haven't had to take away functionality or break something completely yet.
Yeah.
I think it's you first.
I just wonder if you could elaborate a bit on the change to supporting mobile apps. The background is that in your test environment, I have logged on with Android. What does it mean to
Yeah.
support it?
So what's the case with supporting mobile applications? We do support mobile browsers, and now during the corona pandemic, using both vaccination and the tracking of who's been infected, most of those users have actually been on mobile devices, but that's web applications. What we don't really have a good solution for is mobile apps. For in this case, each app must be installed on the device, and each app basically needs its own secret. And we don't have any automated systems for deploying secrets to apps in a good way today. Technically, we support it, but it won't scale. That's basically the problem. So I believe Steinar was going to troll.
Yeah, I was just wondering, you were talking about the ability to change or the rigiditet of a sort of platform that you could use. But can you also perhaps mention a little bit about changing stuff in the tokens? 'Cause that's
Yeah.
that's another issue that's interesting.
Yeah, so the question is, we said that changing features in HelseID is difficult because of the slowness in the ecosystem, but how about changing the content of the security token that we offer?
We haven't mentioned it, but our tokens is JOTS, JSON Web Tokens signed, which contains claims, which is information. And that information is consumed, read by our APIs and clients. So there is a dependency on the tokens. So that is the main reason this is difficult. When we have created a claim and it's official and system uses it, we can't really either change the syntax or the semantics in an easy way.
We're talking about introducing the HelseID token version 2 or something like that, where we basically redo our information model. This is information modeling, and we're talking about using a specification called identity assurance. And you know how it is. We've grown organically. We've added features as we needed them. And suddenly we see that, hey, this isn't good enough. But then we have thousands of systems that use this and depends on it. So we can't just change it. But we are planning on introducing a new format of our tokens. And we need a strategy to migrate to that format. That's going to take a long time. And probably for a while, we're going to include tokens with both the new format and the old format so that APIs and clients can migrate. And then we have to set a date. this day, then you have to go to the new format.
I think there was a question there and there. Take you first.
So I'm just thinking, if there are several doctor offices that uses the same software, I guess still each of them will be a separate client.
Yes, it must, because we are one of the things we do is identify organizations, and that is tied to the client authentication, which really means that they have to have separate secrets. All the other stuff can be the same, but the secrets in the private keys have to be differ between office to office.
This goes all the way down to the protocols and the definition there. So this what we call a client configuration is the username or the client ID and the secret that is basically identifies that client. That points to a single installation of a software. And if you have the same software in two doctors' offices, they are two different installations and they need different configurations. And then we have multi-tenant systems, typically web applications where we have many organizations that use the same software. We're still working on how to model that in a good way.
This means also that if a new doctor's office you want to join you, so to speak, even though they have the same software, you still have to do manual work.
Yes, for one part, the vendor, the one who in fact delivers the software, has to integrate with HelseID, and then we tell them how to do it. So they can use the self-service solution, where you can somebody can log into the self-service solution and kind of just generate what you need to import into the vendor system to make it work. So
it's semi-automatically. Typically, a person who is responsible for the software system at the doctor's office, we log into our self-service system. We use this Altinn service to see that they are allowed to represent that doctor's office. And then they can say, we are using this journaling system and we want the configuration for that system, for our organization. And then they download an encrypted file that they import into their system. So it's not very difficult, but it's not completely manual, but it's not as easy as it should be yet. There was a question here?
Yeah, it was a little bit about what's in the token. How did you design on the strategy for the scopes and audience design?
Yeah.
Because it must be really complex for that big system.
It is.
It was completely random.
Nah,
No.
we were not mature in this when we started building HelseID. It was new stuff, and as far as I know, no one else do the thing we do on the scale we do it in the world. I don't know about anybody. So we started doing our claims today are very basic. You have some information about the national identifier, fødselsnummer. You have some information about how the user was authenticated, on what security level. That is, in Norway you have something 1 to 4, where 4 is really a good authentication and 1 is nothing. We also have the ADAS security levels. We have some extra information which is health specific, some health personal number. We have the names of the person being logged in, and we provide some information about the organization. All this is kind of a flat structure in the token. So it's just claim, 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 claim. Nowadays, the world is moving towards structured tokens, where you kind of, for one claim, you can say something about where is it from, how much do you trust it, if it's an identifier, what kind of identifier is it, etc., etc. Much more complex, but in a way, it's better, but it's more complex. Right now, HelseID tokens are really simple and clean. It's just claim, 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 key value, key value.
But this is...
Scopes in the access tokens to give a resource.
Yeah, we
As well, or is it a lot of...
we do have. They have to be. The thing about the scopes is that they have to be unique on a national level. So an API scope, the name of an API have to be unique. So we do have a way of constructing unique scopes with some namespaces, etc. But that's it. Really.
But The structuring of the scopes for an API, that's up to the API vendor. So some vendors, they have one scope that protects the entire API, while other vendors, they have scopes that go into detail and protect one functionality or another. And that's up to the vendor and their documentation, luckily. Yeah.
That's we spoke earlier about kind of narrowing how we use the protocols. But when it comes to kind of the scope bit, it directly affects the architecture of the API. It's a part of the API design. So we can't kind of say everybody in Norway have to build their APIs in this way. So there you have a lot of leeway on how to do it, really. It's up to the API owner.
We're on time, plus 1 minute. So, any more before we finish?
Yeah.
One final question.
You mentioned that you're using asymmetric encryption.
Yeah.
I assume that you're using that to sign the token.
Yeah, not encryption, signing.
Signing.
Yeah, we do not encrypt right now. We trust HTTPS, so we do not encrypt the tokens. We just sign them.
We are not using the mutual TLS today. Today, each client has their own private public key pair, and we register the public key in HelseID as the secret. And then when a client requests a token from HelseID, they sign a request using their private key, and then we can use that digital signature, verify it against the public key we have, and then validate the information inside it.
It's really a separate topic on how we handle secrets. Yeah. That's one of the more difficult issues we try to solve on this level. But it's a separate topic. We could talk for an hour about that.
Oh, yeah. But on the same page, the tokens that HelseID issues, it's signed by our key, and the public key is public, available from our metadata. So anyone who receives a token from HelseID can download our public key and verify that it is from us. That's part of how the protocols work.
We are on
time. Yeah.
Okay, so, thank you.
Thank you very much for being here.